All right, 4.5, 2 by 2 matrices, determinants, and inverses. So starting off with some definitions, a square matrix is a matrix that is square. It has the same number of rows and columns. Um, the multiplicative identity matrix, or the multiplying identity matrix, that's like the identity when you multiply. For regular multiplication, that's the number 1, right? You multiply 1 by anything and you get the anything, right? 5 times 1 gives you 5, right? The identity matrix for multiplying is going to be the matrix that acts like the number 1 for multiplying. So for any square matrix, there exists a square matrix I, and so that's supposed to be kind of italicized like that, an I, with ones along the main diagonal and zeros everywhere else. Now there's the generic I, meaning the identity matrix, but if you're talking about the identity matrix with a specific dimension or a specific size, you put a little subscript down at the bottom. It might be like an N, right? So I2 means a square identity matrix, or the identity matrix that is a 2 by 2, right? And the ones are along this is called the main diagonal. For a 3 by 3, it's the ones along the main diagonal still, and there's 3 of them. Next up, the determinant of a 2 by 2 matrix. The determinant is a number that we can get from the matrix, and sometimes it's written as det or det of your matrix, or you could also say like det of A, determinant of A, and that's how I will end up normally writing it. If we have matrix A written somewhere, I'll say determinant of A equals and then blah. So you can either say determinant of A, determinant of the matrix, and you actually list it, or you could do these vertical lines, and they kind of look like absolute value bars, right? They mean find the determinant. It's another way to symbolize it. And something that we're going to probably, or you're probably just going to want to remember, is the determinant of a 2 by 2 is AD minus BC, whenever the A's, B's, C's, and D's are written like shown. The inverse of a 2 by 2 matrix. A note about it is that when you multiply inverse matrices together, the product is the identity. And the way to think about that is if you have x and x inverse, right? It's not quite x inverse. We kind of think about it different ways. X to the negative 1 is really 1 over x, right? But if we take x times 1 over x, we get 1, right? X times 1 over x, you get 1. That's the way to think about this. And we're going to use this in problems because we're going to really want to kind of divide a matrix. But we're not going to be able to divide the matrix, but we can multiply by the inverse. And that's kind of how we're going to get around solving some of these. So what did I say? The inverse of a 2 by 2 matrix, you kind of think of them as a pair, right? You have two matrices that are inverses of each other, right? And when you multiply them together, the product is the identity. So on your homework, there are 3 problems, I think, where it asks you yes or no. Are these two inverses? And what you're going to do is you're going to multiply them together, and you'll see, do I get the identity, yes or no? If it's the identity, then they're inverses. If not, then no. If the determinant is 0, then there is no inverse, and I'll show you why that is in just a second. So if we have matrix A here with A, B, C, D, A inverse is 1 over the determinant, right? So right there we should be able to see that determinant can't be 0 because that would make the denominator 0. And that doesn't work. So that's why the determinant cannot be 0, right? Or the determinant cannot be 0 if we're dealing with inverses, right? The determinant can sometimes be actually 0. And then we have this matrix here. I'm going to call this the alt A, alternative A, right? So what we do here is you'll see that the things along the main diagonal swap spots, and the other two go negative, right? So the A inverse is 1 over the determinant times the alternate A, or the alt matrix A. So number 1, we're supposed to simplify here. And we have matrix A, which is listed, and then we have the actual statement tells us A times I2, the identity matrix that is square with 2 by 2. So I should say 10, 3, 6, 4. Then the identity matrix is 1, 1, 0, 0. Right? Now, let's actually multiply this out. This will give me a 10 plus, here, I'll write the whole thing out. Uh, 10 times 1 plus 3 times 0. 10 times 0 plus 3 times 1. 6 times 1 plus 4 times 0. Then lastly, 6 times 0 plus 4 times 1. When we simplify that, we get 10, 3, 6, 4, which is matrix A that we started with, right? So the point of example number 1 here is to show you or to prove to you or to convince you that the identity matrix does work like the number 1, right? It gave you the original back, right? We learned here that A times I gave me A right here, right? There might be something on the homework, either this homework or maybe another one that has something like that to where you could either go about it the very hard way or the really, really easy way. Just recognize that, well, it's times 1, so you get itself. So that's something to keep in your mind. Next up, evaluate the determinant of this matrix. So here it's written as determinant of the matrix. It's all written there nice and pretty. And you should be standing over here, and I told you guys to remember something. I told you to remember that AD minus BC. All right, that's the thing to remember. That is the formula for determinant. So determinant is going to be equal to 3 times negative 3 times negative 5 minus 4 times 2. So 15 minus 8 gives me 7. The determinant is 7. All right, next up, it's asking us, does A inverse exist? All right. This is a similar problem to number 2, the one that we just looked at, because really what it's asking here is the determinant 0? Right? Right? That would be another way to word this, to ask it. Right? Because we know that if the determinant is 0, A inverse does not exist. And if it's anything else, it exists. So determinant of A, we still remember it's AD minus BC. This is going to be 3 times 6 minus 9 times 2, 18 minus 18, 0. So A inverse does not exist. Or you could write it all out. Does not exist. Alrighty. Next up, we are actually going to find an inverse, or at least if it exists, we're going to find the inverse. Something to remember: the formula here is A inverse is going to be 1 over determinant of A times like alt A, right? So we have 2 pieces that we're going to have to find here at the beginning: the determinant and alt A. I'm going to start off with the determinant. Well, that's AD, so negative 2 times negative 4, minus BC, 2 times 5. So this will be 8 minus, no, that's not right. Yeah, 8 minus 10, there it is, which is going to be negative 2. Now for alt A, Well, if you remember right, we switched the major arc. So this is going to be a -4 and -2. We swap their spots, and we make the others negative. Or maybe the better way to word that is we swap their sign, right? If they're positive, we make them negative. If they're negative, we make them positive. Now we can actually plug in and solve. So I'm going to have 1 over -2 times my big, what is this called? The matrix. This will give me 2, 1, 5 halves, 1. And this is A inverse. Alrighty, there we are. That's example number 4. Now number 5. Now we're putting it all together. This makes it a little bit harder, and this is kind of what we're all working towards. If we had this, and I'm going to reword this and say that this is A and this is B. This is A times X equals B. AX equals B. All right. If it was written like this, what we would do here is we'd divide by A, and then we'd get X by itself, right? We'd say, well, X is equal to B over A. No dip, right? We can't divide matrices. We don't know how to do that. So we're going to have to find another way to do that. We know that A inverse times A or A times A inverse is 1, right? And that's the idea we're going to use. What we're going to do is we're going to multiply both sides by A inverse, right? We have A. If I were to change this to A inverse AX, well, really that's just X, right? Now we did it on the left side, so we have to do it on the right side. And this is where it gets kind of a little bit tricky, kind of confusing here. I put the A inverse on the left, on the very farthest left. You have to do the same thing on the right. Right? Remember that matrix multiplication is not always commutative, right? It's not the same thing as just because with regular numbers 5 times 3 is 3 times 5, that doesn't mean that that's the way it works for matrices, right? So we cannot swap them. We have to put the A inverse first, right? That's going to be a big thing. So we're going to try to rearrange the equation on the left here to where it's X equals A inverse B. So the long part of this, the longer piece of this problem is going to be finding A inverse, right? We know what A is, we have to find A inverse, right? So I'm going to pause the whole solving part of it, and we're going to find A inverse right now. So we know that A inverse is 1 over the determinant times alt A. Our determinant, or maybe I should say determinant A right there, is -2 times 3 minus -5 times 1. So this is going to be -6, -6 plus 5, which is -1. Alt A, where do I want to write that? I'll write that here. Alt A is going to be, you swap the spots on the major arc, or the major diagonal, and then swap the signs. Now I'm going to multiply these together, so A inverse here, maybe I'll change colors. A inverse is going to be 1 over the determinant, so 1 over -1, which is really just fancy multiplying by -1. And then I'm going to have 3, 5, -1, -2. So really I just have to swap the signs now, and I have -3, -5, 1, and 2. This is A inverse. Now I'm ready to actually solve and get my final answer. So I go back up here and I use A inverse B, So I'm going to multiply A inverse B. So I could say here, I don't know, x equals A inverse, which is -3, -5, 1, 2, times B, which is -2, 2. And we're going to multiply those. Notice that this is a 2 by 2, and the second one is a 2 by 1. So we can multiply them, and our result is going to be another 2 by 1. So we'll do across the row, down the column. So that gives me -3 times -2 plus -5 times 2. And secondly, for our next row, same column, that gives me 1 times -2 plus 2 times 2. All right, finishing it up, I'll have, what is that, 6 minus 10. Is that what I got earlier? That is what I got earlier, good. And then I have -2 plus 4. And finally, I have -4, 2. And there we are. That's a long problem. And if you really, really wanted to, you could go back and you could multiply A times X, and you would end up getting B. So that is that. Make sure make sure that you have all this stuff written down, right? Go back and pause the video if you need to. One of the things that sometimes hard to remember is the inverse piece here. So that would be a good thing to either commit to memory or write it down on a note card, and the determinant as well. Both of those are things that you'll need to use pretty regularly for the rest of the chapter. So, alrighty, that's all. Good luck.